Hello, welcome to this fourth video in a series about experiments in the digital age. This video is about zero variable cost data and the music lab. This material is covered in chapter 4 of Bit by Bit. So last time I was at Stanford, I talked to a lot of people about their research, and it was always about doing something at scale. So I study X at scale, I study Y at scale. And so one way to think about this talk is it's about experiments at scale. So I want to talk about first why I think scale is so important. To me, this is one of the most exciting things about experiments in the digital age, is that we can do them substantially bigger, hundreds of times bigger than we could do experiments before. And this will allow us to do stuff that no one has been able to do before. And it will even allow us to do stuff that no one had even imagined before. So given the possibility of running an experiment hundreds of times bigger than in the past, I think if we just do what people have done in the past 100 times, that's really a failure of imagination. I think this is a real opportunity for us to do things that people have not imagined before. And so in this video, I want to talk about how you can do experiments at scale and what are some of the limitations of that as well. So to understand what I mean by where I think the power comes from to get experiments at scale, it comes from having zero variable cost. So this graph shows how the cost of an experiment increases as the number of participants increases for an analog experiment. So there's low fixed costs, like it's relatively easy to get the first couple of experiments, but then if you want to double the number of experiments, it costs twice as much. If you want to 10x the number of experiments, it costs about 10 times as much. Digital experiments have a different cost structure, so it costs much more to collect the first piece of data, but then each additional participant is almost free. And so with this zero variable cost, you can run very large experiments that were not possible otherwise. So how do we get zero variable cost data? I think at first it comes from thinking about what are the sources of variable cost, and I think the two biggest in experiments are staff time and participant payment. So staff time would be, if you're doing an analog experiment, it requires people, for example, to deliver the treatment, measure the outcomes. People are expensive. Also participant payment. Many experiments are not enjoyable. They're not things that people would choose to do naturally, and so we have to pay them to participate. That creates variable cost. So how can we eliminate these sources of variable cost? One is we can have automation. So your experiment should be able to run while you sleep. And if your experiment runs while you sleep, you've probably done a really good job of eliminating the staff time that's needed to make the experiment go. And then second, we can design enjoyable experiments. So to the extent that our experiments are automated and enjoyable, we can potentially get zero variable cost data, which will allow us to do experiments at scale. So now I want to tell you about an example of one of these kind of zero variable cost experiments. This is my dissertation research. It's called Music Lab. This was done with my advisor, Duncan Watts, as well as others. Peter Dodds, Peter Housel was our web developer, Jason Brewer-Jennings was our designer. And so this is the website that we built, Music Lab. So you can see that it's clearly labeled as a university website. We have the Columbia logo, that's Columbia Blue, it's a Columbia URL. And so it was very clear to people that they were in an experiment to study musical taste. And so after people clicked here to start the experiment, they were taken to a screen where they provided informed consent, and then they were given a short survey to collect some basic demographic information. After that, they were taken to a screen that looked like this, which included 48 songs by up-and-coming artists that were at that time relatively unknown. These include bands like Stunt Monkey, Not for Scholars, Star Climber. And so the idea was that we wanted these bands to be unknown to participants so that the only information that they had about the bands and the music would be this information that we provided them here, which is the number of times the song had been downloaded previously. So a participant is then able to click on a song that they would like. The song starts playing, and they're asked to rate it on a scale of 1 to 5 stars. Streaming audio on the internet is now an easy thing. At the time, we were somewhat worried that we could even make this work. After they click their rating, they're asked whether they would like to download the song or not. And so here you can see in the structure of the experiment, we have a self-reported measure of liking in the ratings, and we have a behavioral measure of liking in the downloads. And our interest was really in this behavioral measure. And so that's the measure that we analyze subsequently. It turns out that the self-reported behavior and the self-reported liking and the behavior are strongly related in this case. So after they choose to download the song or not, they're taken back to this menu and they can listen to as many songs as they like. So that was the experience of a participant. Now, let me tell you a little bit about what motivated this experiment. So it was motivated by things like Harry Potter. So this is the first book from the Harry Potter series. Harry Potter was wildly successful. It sold millions and millions of copies, translated into more than 60 languages. But yet, that success was very hard to predict ahead of time. So Harry Potter was initially rejected by 8 different publishers. And it seems like a strange combination that something that went on to become so successful was so hard to distinguish ahead of time, even for people whose job it is just to find the things that will become successful. And so it turns out that's not specific to Harry Potter. I could have told you a story like that about the movie Star Wars or the TV show American Idol. And it turns out that this is a general pattern in the nature of success for cultural objects like books, movies, art, TV shows, and music. That you see, on the one hand, extreme inequality in success. These are sometimes called winner-take-all markets or superstar markets. And that would lead you to believe that these winners, these superstars, are somehow different than all the other objects. But yet, at the same time, there's tremendous unpredictability of success. It's estimated that something like 90% of artists signed by major record labels lose money. And so it seems strange, again, that these two things co-occur. And what we were trying to argue is that both of these collective level patterns can arise from the same individual level process. That is, if people are influenced by the behavior of others, that can lead to a process of cumulative advantage whereby successful things become more successful. And that cumulative advantage can lead to the inequality in success. And that cumulative advantage can lead to the unpredictability of success, because one time the process can form one way, another time the process would evolve in a very different way. And so these two things that seem to be inconsistent at the aggregate level both arise out of the same behavior at the individual level. So that's the argument. And now this argument, if you don't like Harry Potter, maybe this argument is convincing to you. That is, Harry Potter is just the result of some luck and a cumulative advantage process. But to many fans of Harry Potter, that's totally wrong. Like my son loves Harry Potter. He would never be convinced by this argument. To them, Harry Potter was successful because it was great. And there's no way to resolve this just seeing one outcome of the world. So we've seen a world where Harry Potter is successful, and that could be because Harry Potter is great, or it could be because Harry Potter is lucky. And with just the one piece of data that we have, it's hard to resolve. But now imagine if we could rewind the world to the day that Harry Potter was first released and make 8 copies of the world and have them all evolve independently. Now, if Harry Potter becomes popular in all of those worlds, then we would have to say that it's a really good. If Harry Potter becomes popular in one of those worlds but not the others, then we could say that it's lucky. So really, to see the role of chance, we need to see multiple realizations of the same process. We need to see these multiple parallel histories. And that's something that we cannot do in the real world, but we can potentially do in an experiment. And that is what we did with the music lab. So when participants arrived at the website, they were randomly assigned into 2 different conditions, the independent condition and the social influence condition. In the independent condition, they had no information about what other people were doing. So they didn't have any information about the number of times the songs had been downloaded. In the social influence condition, they could see what other people were doing, but critically, each participant was assigned to one of 8 worlds, and they could only see what other people in their world were doing, not anything about the other world. So it's like putting these people in a room. You can see what people in your room are doing, but not what people in the other rooms are doing. And so through this, we are able to create these parallel histories where we have the same 48 songs with indistinguishable groups of participants, all starting from the same initial conditions, and we can see to what extent the outcomes are the same across these parallel histories are different. And then by comparing the social influence worlds to the independent world, we can also learn about the role of social influence in inequality and unpredictability. So overall we ran 4 experiments. I'm just going to talk about the first 2 in this video. The one on the left, less social influence, that's the one you've seen before. This was the first experiment we ran. Then in the second experiment, we wanted to see if we increase the amount of social influence at the individual level, will that have the predicted results at the aggregate level? That is, if we increase the amount of social influence, do we see more inequality and more unpredictability? And so to increase the amount of social influence, we changed the design of the screen to rank the songs in order of their popularity in a single column, which makes the popularity information much more salient. So were participants aware, was there any social influence going on at all? So this plot here shows the probability of listening to a song as a function of its rank in terms of market share. So market share is the percentage of all downloads that belong to a specific song. And so the blue dots show that in the social influence worlds, people were more likely to listen to the more songs with higher market share. In the independent world, it was flat. The probability of listening was basically independent of the market share. So people are being influenced by the popularity information. And in experiment 2, they are more influenced by the popularity information. So in experiment 2, the probability that someone would listen to the most popular song was almost 0.5, whereas in the first it was about 0.2. So the change in the design that we made of the listening screen had the effect that we thought it would have at the individual level. And now let's look at the consequences for aggregate behavior. So here is the inequality of success of the songs. The dark gray bars are the 8 social influence worlds, and the light gray bar is the independent world. And this inequality is measured in terms of the Gini coefficient, and we see that every social influence world was more unequal than the independent condition. Here are the results from experiment 2. So the inequality measured in terms of the Gini coefficient increases. The most equal world in experiment 2 was more unequal than the most unequal world in experiment 1. So there's a real increase in inequality. The median Gini coefficient changed from about 0.34 to 0.50. So most people don't have a ton of experience working with Gini coefficients, but this is similar to the difference in income inequality in France and Nigeria. So if you think France and Nigeria are different in terms of their income inequality, that gives you a sense of the scale of the change as we increase the amount of social influence. Now, we also hypothesized that there would be an increase in unpredictability. And let me say that this is not, to me, totally obvious that this would be true. So sometimes we have this idea that having information about the behavior of others will help people all find the best songs faster. So you might speculate that maybe this increasing the salience of the popularity will just help people pool their information faster, will help everyone find the best songs faster. So maybe that's true. Let's see now, how are we going to measure unpredictability? And so these are 2 songs. There are 8 data points for each song because there are 8 worlds. And this shows the market share of these songs across the 8 worlds. And so what you see is that Fear by Fourth Fading, the market share is more spread out than it is for Inside Out by Stunt Monkey. And so we would say Fear by Fourth Fading is more unpredictable than Inside Out by Stunt Monkey. And so more formally, we define the unpredictability to be the mean difference in market share across all pairs of realizations. And so this unpredictability is inherent in the system, in the aggregation dynamics. And it can't be resolved by more information about the song, because this is exactly the same song competing against exactly the same other songs with indistinguishable groups of participants starting from the same initial conditions. So here are the unpredictability in experiment 1. We see that it's higher in the social influence condition than in the independent condition. Here's the unpredictability in experiment 2. So it increases by about 50%. And so what we see is experiments 1 and 2 together showed this dose-response relationship where increasing the strength of the social influence led to increased inequality of success and increased unpredictability of success. This design also allows us to study the relationship between quality and success. That is, we can look at the popularity of the songs in the independent condition, the condition where people have no information about what other people are doing. And that gives us a pretty good measure of how much these participants liked these songs. And then we can compare that to the success of the songs in the social influence worlds. And so here are the results from experiment 1. The x-axis here is the market share in the independent world. As I said, that's a measure of the appeal of the song or the quality of the song. The y-axis is the market share in the social influence worlds. And so before I was talking about unpredictability, it's clear that the results are not purely random. That is, you see, as the appeal of the song increases, the success also tends to increase, but there is still a big range of outcomes that are possible. Now, here are the results from experiment 2. And so we see a very different pattern. The amount of variability in success is increased, and the pattern now much more looks like a cone-shaped structure. So you can see like these songs pretty much never do well, but these songs, there's a big range of possible outcomes. So to make this concrete, we had one song, Lockdown by 52 Metro. In one world, that song came in first. In another world, that song came in 40th out of 48. And that's exactly the same song competing against exactly the same set of other songs. It shows how much variation in results can occur when there's this process of cumulative advantage. So during my dissertation, I talked to a lot of people about this experiment. I talked to a lot of people who knew. I tried to, as much as possible, learn from domain experts. So talk to people who work in the entertainment industry. And I had one great meeting with the head of research from NBC. So I was a grad student at the time, and I got this meeting, and I went into his office, and he has this beautiful office overlooking in Rockefeller Center. It's just amazing. I tell him about the experiment, I show him this graph, and he said, "Oh, I knew that." And I said, "You knew that? Great, tell me about that." And he said, "Well, I can predict failure, but I can't predict success." And to me, that is the best description of what we found in experiment 2. That is, the songs that are low appeal are never successful, but the songs that are high appeal have a big range of outcomes. Even the highest appeal songs are not always the most successful. So we found that more social influence leads to more unpredictability. You can predict failure, but you can't predict success. And I would encourage you to read our paper with more details about the experiment. So now that you've seen the experiment, I want to highlight again the importance of zero variable cost data. So that allowed us to run this experiment with 27,000 participants. And now in computational social science, 27,000 is not a big number. But I just want to take a second and think about how big that number is. So imagine if we had all the undergrads at Princeton be in the experiment. That's roughly 5,000 people. That's like not even close. Imagine if we had all of those students plus all of their family members. That's still not enough. Imagine if we had filled up Madison Square Garden and had all of those people participate in our experiment. That would not be enough. So, but what 27,000, what that enabled us to do is have an experiment where the unit of analysis was no longer the individual, but it was the group. So, right, the collective outcome, we were able to generate lots of these parallel worlds. Each of these worlds had about 700 participants. So it's very expensive to generate one of these parallel histories, but because we had zero variable cost data, we were able to do this. And so we're able to now create experiments where the unit of analysis is not necessarily just the individual. It can also be this collective outcome, which is, I think, particularly important to sociologists who are very interested in how collective and societal patterns emerge out of the behavior of individuals. And so here, zero variable cost is not just a cool thing to do. It really enabled us to do something to create these parallel histories that was basically impossible to do without taking advantage of digital infrastructure. So for example, in the design of the experiment, we gave participants access to free music. That means the thing that drew them into it cost us more to build the website initially. So initially it was much more expensive, but the variable cost was basically the cost of the web server, which was free. If we had done Music Lab without free music, then we would have had a much more difficult cost scaling because we would have been paying people, and so to double the size, we would have had to double the budget and for participant payment, and 10 times the number of subjects, we would have needed 10 times as much for participant payment. So I want to clarify also, in this case, that took a lot of design to align the thing that we were studying, that is social fads, with a behavior where the experiment would be able to be enjoyable and self-rewarding. We did this, also I want to clarify, we had the permission of all of the bands. So in general, the bands were very excited about getting more exposure to the music. And also we were able to give them something interesting, which was like a market research report. So we have a bunch of data about how people are interacting with their songs, and we're able to provide them an aggregate report about what kinds of people were listening to and downloading their songs, something that they found really valuable. So that increases the fixed cost because I had to generate all of these reports for the bands. But it, again, decreases the variable cost because we don't have to pay the bands to use their music. We're providing them other things in exchange for using their music. So with design and thinking about all the different partners and elements of the experiment, it's possible to get these zero variable cost experiments. And this is not an end in and of itself, but it's a means to an end. It allowed us to create these parallel histories, which allowed us to study social fads experimentally in this new way. So now I want to highlight an important point about zero variable cost data. It's important to keep in mind who bears the costs and whether it's actually zero variable cost or zero variable cost to you. So this is a study by Catherine Milkman and colleagues. And what they did is they sent emails to professors kind of like this. I didn't receive this email, but they sent emails like this. I am writing you because I'm a prospective PhD student with considerable interest in your research. My plan is to apply to PhD programs this coming fall, and I am eager to learn as much as I can about research opportunities in the meantime. I will be on campus today, and although I know it's short notice, I am wondering if you might have 10 minutes and would be willing to meet with me briefly to talk about my work, and so on and so on and so on. Thank you for your consideration. Sincerely, Carlos Lopez. So what was happening here is the researchers were interested in to what extent professors would take these meetings as a function of two things: the gender and ethnicity as signaled by the name of the respondent, and the time frame. So whether you would be willing to do the meeting today or next week. And so here's what they found. So they found that in general, professors were more willing to, for the requests that were for now, like today, professors were equally likely to take meetings with Caucasian male students and other students. But for requests that were in the future, the professors were more likely to take meetings with Caucasian male students. Also, because this data was very cheap for the researchers to generate, they were able to send, because for them it's sending an email, it's free. So they were able to have a very large experiment which allowed them to explore a number of different combinations of gender and ethnicity. So let's think about what are the fixed and variable costs for this experiment. So it seems like this might be a zero variable cost experiment because for the researchers, sending the emails are basically free. However, it actually has a cost to the people who are receiving the emails. So let's imagine that they sent out 100,000 emails. It took 1 minute per faculty member to respond. So then they've just kind of consumed 100,000 minutes of faculty time. And so it's important to remember that there's a difference between zero variable cost and zero variable cost to you. So in this case, it was zero variable cost to the researchers, but there was some cost. Whereas with the Music Lab, people opted into the experiment because they found it enjoyable. So just to be clear, Milkman and colleagues were very aware of this issue. They deal with it sensibly and responsibly in their paper. I would encourage you to read that part of their paper. So I'm not bringing this up to criticize the decisions they made, but I'm bringing this up to highlight the difference between zero variable cost and zero variable cost to you. And if you are doing things that involve conscripting people into your experiments, then I hope that you will be careful about how you do that. You will think carefully about the ethics of that. So I've tried to give you this capability to teach you how to make zero variable cost experiments, and then also thinking about how to use that capability responsibly. So that brings us to the end of this video. This is the fourth in a series of 5 videos about experiments in the digital age. The next video will be about the 3 R's, another approach to thinking about ethics in experimentation. Thank you.